So what you're doing this problem was, we're all supposed to have science memorize. On the time to one minus two minus T2 over 3 factorial. Either 6 over 5 factorial, so on. So now I want to divide that by T. So we just divide every term by T. Divide by 2 is 1. T over T is 6 over T is 4. And so on. Because when we look at what I'm done. Y'all want to see that once I fix the answer. At first it said like 4% of you guys right, but I think it's really like 60%. This question is not asking you about a series, it's asking you about a sequence of series don't converge on the position. Sequence converges if all the numbers are in close to a number. In other words, you should check the one and we don't want to go off. If we put 5 halves, this one, 2 over 3, they have to be what? 2, we have to do 1, this one, we can do another 10, 1, so 1 to convert. 1, 2. And that's different than asking if it's series converge. All of these series are divergent because it's divergent stuff. Don't you put it here. But for a series, it doesn't affect it. That's not what we're looking at. Don't be shy to ask questions. I will pause. Derivative. We take a derivative of something. Just fancy polynomial. Only for that type everything is we do the derivative of a polynomial. Time is derivative of this guy. It's only neighborhood and you're the third right form. Derivative is the way it's done. Type of question. Slide down. When you see about the 2 minus 1 now. Go to the exponent by 1. And we'll return minus 1 still. Constant doesn't change. Things cancel out. Because the left is a. So this one was going to follow. I think it looks scary into all the things that the text is one time fast. You're welcome to review it again. Kind of looking for a series to converge. If you guys remember that one page that we had for the unit series and like all steps on one page, that's the one that you need tonight. You just instantly look at this one and think it's converged. Is that negative 1 here plus 1? And this goes to 0. This goes to 0 and alternating. These two are both a little harder. You see an N, you might need to get that. Kind of messed up with it. So we have kind of a backup plan that we use on the horse. So, ratio test. Ratio test says if you get a limit less than 1. I don't know if I remember what the ratio test is. Obviously, we all know that if we get a limit less than 1, it's going to be greater than 1, so we have the one. Probably easier to back up. So these are ratio tests. The reciprocal of the original. And we will find this limit as an approach to infinity. Certain things cancel out. This whole piece is an approach to infinity. So let's see. We have a number bigger than 1. So this series must. That one's up. Which can help us pull out some answers already. You know 1's going to work, 2 is not. So we've got 50% chance of guessing right now. We may use the ratio test instead of the comparison test right now. Run a comparison test. Run a comparison test says if you get a number for an answer. Both series converge or both series diverge. I thought this one was kind of hard. Test me what value if this series converge. Probably helpful if you write it as converge. Like this. And the way I thought about this is instead of saying what x was 0. You can use 0 power as well. 1. You add up 20 ones forever, then you need to bring it every. X can't be 0. That helps you get rid of all of them. E has to be gone, so x can't be 0. X can't be 0, so x can't be greater than negative 1. Or greater than or equal to negative 1. So now I'm narrowing down to 50%. Then I just decided to choose a value less than negative 1. That's a good choice. Negative 2. So it's negative 2. And then when I write this, that looks like a certain thing. Which is converge or diverge. Converge. So x works for at least negative 2. There's not going to be no value of x. Process of elimination, the answer must be. It turns out this is P series anyway. It becomes into the x equals 1 over into negative x. We want this number to be bigger than 1. There's a couple ways to do that. P series is a big one. Ratio test is a big one. It'll help you on the test. So again, the other series calculator one has to put the maximum value of this guy. I'm going to go through all of the columns and set it up. So do this. The first C on the room. I have to figure that out by plugging in the value of 10. Plugging in 1. Plugging in equals 1, you get negative 1 to the positive. 1 is 1 to the first 1. Minus. X 1 is 1. Negative 2. asking us for the maximum value of success. And we calculate this. Type in maximum value of minus probably going to use that one as what? Or distribute your minus sign. Other things I should mention? A good X minimum and a good X maximum for the graph. And we can use the graph. Let's take the volume. Or the graph. Based on the given information. Let's plot the good X min, X max. And the given information. Okay, so I get my Y values from I need to lower the zero now. Zero is probably displacement. And the stopping point is probably like 5 times maybe. That's zero. So I type in that one. So you got the calculator, we see the minus one on the far left. So 0. So get into the vector 1.5. I'll probably take more than 3 minutes, but these questions are supposed to be about 3 minutes on average. That's the more straightforward one. Some probably take 3 seconds to know what you're doing. Actually, it's something virtually. That's just where you are. Actually, there's something not converge. And either. Series shows that here is not greater than. You see that negative one being on the last one, what kind of series? Alternating that goes to 0, so we say yes or no. So yes. If it's alternating and the number gets closer and closer to 0, then we show up with 1 and 2. I think we saw one, is that one there as well? Yes. We must have been on both versions. So, not do that one again. I think there's like 4 or 5 that were on both versions. So I ended up putting on more than one side. What indicator will both of these converge? I think you can do it converge. Because I look at that and think that's kind of serious. Main force. Geometric. And is total force going to be okay for that? Converge force? To convert, we need that number to be less than what? So if total force is not going to work, 5 force is not going to work, the 1 force is not going to work, 3 over 4 and 2 over 4 are both okay. Let's go to the other one. The other one, by putting in 3, you negative 1, 3, 1, that's alternating. This becomes okay. Putting 2, and negative 1 is 2 again. There's something an even power that makes it do what every time. Positive. This is really the same thing as 1 over 10. Where did that work? Over 2 even. Power series. You might think you use that because you use power, but that's where it's in next to the up. So we have to go back to the ratio test. So we got a ratio test. So times the reciprocal of the original. This specified earlier, we want this number to be less than 1 for converge, greater than 1 for diverge. Okay, less than 1 because we'll reach the test. These numbers will be less than 1. Things start canceling out. N goes to infinity. This goes to 1. So we'll do x plus 2 plus 1. Not subtract 2 from both sides. Just write out the 2 problems first. People who subtract 2 from both sides are going to get these subtracted back here. We got to show you x is less than -1, x is greater than -2. If we have a test of what? This one. We try -1. If -1 here, we get -1 plus 2, positive 1, so then, take the series. 1/2. Convert diverge. Diverge gets to be greater than 1. The -1 does not work. Go away. Look at A and B. So we are -3, -3 plus 2, -1 again. This time we're going to be calculating that step. So -3 is okay. On the power series, you have to set power series because what is going to go in the power series, not the exponent. And then there's a variable other than him that makes the power series. We have multiple answers. This is the same problem as the last one, just different expression. Not going to do this one. It's going to be the same thing, no user ratio test. Check your endpoints. This one I believe people would miss just because of notation. Asking for forgiveness. And it's telling you, you know that A is another constant. So we're going to find forgiveness. Then find that Mary -1, dropping that x1. So x1 was 1. X0 is just 1. And I think that gives us answer. And that x is x to 1 minus 1. Look at the derivative, put in 1, down there to 1. That one, let's go to this. Yeah, let's just. So I made a mistake. This is not x to the 1 minus 1. 1 is 2 minus 1. It is still equal to 1 plus 8. So we have to go to vector of equal. You're immortalized on YouTube now. Before we go to power series, we have to ratio test. And then start the endpoint. I'm guessing these ones will be in the practice. I'm not going to go with them. It's the same as the one we already did. It's different numbers. This is the following series converge. If you look at this increasingly series divergence because of what test? What test? Instantly look at this one and say this is divergence because of series. T is not greater than 1. The only possible one that you can convert is 2. 3 versus 2. 3 versus 2. Cosine of n pi is probably a bit scary. That's just a little earlier. 2 is 1. Cosine of pi is 1. Cosine of 2 pi is 1. Cosine of 3 pi 3 can be by 3 as well. Alternate. I can decide to put in the regular language. It goes to 0, 15, and 0. It could also be just if you don't like that on the test, or the next. That would be the exact same thing. If you have 1 negative and 1 negative. So be on the lookout for that. So they will be signed up to equal to, they have to say that. So they go to take it. Now that's the coefficient of x to the 7. That's fine, that's the formula. Let's talk about that. That's fine, that's and they want the coefficient of x to 7 to be anti-derivative with this. We want that's the polynomial, so find this, but I get them, get the wrong person, the whole data. 7. And so we integrate that time, and make it x to 7 over 7 times 2x2. And my coefficient of that is negative 1 over 7 times factorial. That's just 7 times factorial. That's 7 times. I think it's good to track it with one of the things more. This one was for people who are really not good stuff. We've got a couple of things. First of all, you know the PDF is multi-plus text, plus text. Think about the differences between PDF and so since it turns out to be really, you have now you get the graph over those, you calculate, and see where they intersect. So, if you have transformation, maybe you have trouble coming up with, I think you've gotten right into it, if you would have instead just typed in like the fourth term when you calculate and it's going to be calculated. I bet that would have narrowed the answer down at least. There's that this I think is talking both. what I would do if I was coming up with something. This is what I have. You don't remember how to find the intersection of two curves? You're out of luck. You ready to look at this one? I'm not going to look at it again. This one's a geometric series in disguise. Testing for f of 1, which is usually 1 into I don't know what sign of 1 squared is. Just figure out what that is. Then you should realize, convince yourself how you know that this is a geometric series. Radians of degrees. Put your calculator in radian mode right now. That's what we do again. I'm rounding. What should I really round? And so I might really store this into A on my calculator. And once I realize this is a geometric series, I'm going to use my formula for some of the geometric series. And the only formulas we know to get from be our first term, which is the 0.708, over 1 minus r. In this case, r is also 708. And that's about 2.426. Done. Reason I know the first term is 0.708, I'm putting in down, okay? The reason I know r is 0.708 is r is that. But the first term and r always the same. This could have been a k minus 1 or k plus 7. That would change the first term. Or this could start with k equals 10. So first term and r are not always the same. This one's already been on there, so I'm not doing it again. It's like the fifth time we've seen a problem like this. We have to start the series first. 1 over n squared, we should know that's what kind of series. P series is greater than 1, not good. P series P equals 1, good or bad? Have to know that. Left hand equal 1, diverge. This one is a little different. Alternating, that's a good sign. So if we get really big, it's something that's close to 0. That comes like converge. Oh, 1 and 3. So that's 1 and 2 is 1 answer for this one. This one very good. I'm doing it again. We just did one kind of like this. This is another one-part series. That's a little weird though. Not such a 0 or 1. Yeah. And we want our first term. So by putting in 1 over 3 n over 1 minus r. And if you look at that answer to it, it doesn't clean itself out right now. So doing a little simplifying, I'll make it. For instance, 1 minus 1/3 is 2/3. You don't know what to do with that bottom fraction. Good. We have times 1/3 at the end. If somebody shows up with 1 minus 3. once again, this comes from knowing the formula, first term over 1 minus r. The only formula you have to know as far as I recall on series. So this is very key on either dx. Since that's not either dx equals. And I think it's all the form already, right? If you want to do the x still, do that. And we care about the x term. And then do that x still, do that. And find that coefficient. Here is 27 over 6, 9 over 2. Done. Not too bad, unless you don't know the extension for e to the x. You don't know the extension for e to the x, you have to go through that process of figuring out the expansion. Hopefully you have those formulas figured out. They'll probably show up on FRQ. But anyway. Saw that one already? You saw that one already? You saw that one already? I know you. Coefficient for x is 6. Sin x squared. You know what sin x is? X minus x equals plus x squared plus x equals plus x squared. Close and such form. And we want sin x squared instead. So the x squared. And we want the coefficient for x is 6. Right here. Negative 1 over 2 factorial, which happens to be negative 1 over 6. And move on to the right. And I just realized I have no idea if it's sound recorded because I'm not wearing my headset. So hopefully the computer picks up good enough. Sorry.